Hello everyone, in this video let's discuss about 8:1 multiplexer construction using 4:1 multiplexer. So if I consider 8:1 multiplexer first, there will be 8 number of inputs. So there will be 8 number of inputs. I will call them as I0, I1, I2, I3, I4, I5, I6 and I7. So therefore 0 to 7 means 8 inputs and there will be a single output. And these inputs, that is I0 to I7, will be selected and gone through the output Y by the selective lines, by the help of the selective lines. Therefore the selective lines will act as an input in the multiplexer. So how many numbers of selective lines we required in 8:1 multiplexer means, what is the input value? That is 8. How you can represent 8? So 8 can be represented as 2 powers. You must represent it in 2 powers. So 2 power 3 is 8. Therefore 3 number of selective lines are required. If it was 4 means, how we will represent 4:1 multiplexer? 4 inputs will be there, no? Here, how we will represent? 2 power 2. So therefore 4:1 multiplexer need 2 selective lines. So I will call them as S0, S1 and S2. So these are my selective lines of 8:1 multiplexer. So in 4:1 multiplexer, we will be having 4 inputs and 1 single output, and as we discussed, 2 selective lines will be there in the 4:1 multiplexer. Now using these conditions, we will be drawing the 4:1 multiplexers, and using those 4:1 multiplexer, we will be constructing the 8:1 multiplexer. So to construct them, we just need 2 4:1 multiplexer, 1 and 2, 2 4:1 multiplexer. So therefore 1 output, 1 output, that is 4:1 multiplexer. No, these both are 4:1 multiplexer. These both will be having 1 output, 1 output. But I must get only single output. That is 8:1 multiplexer I am constructing. So I must get only 1 output. So I will add OR gate to them. If I add OR gate to them, I will get a single output. Next, so I must depict the 8 inputs. So here in 4:1 multiplexer, I will represent I0, I1, I2, I3. Next, I4, I5, I6, I7. Now the inputs and the outputs condition is satisfied because 4 input, 1 output, 4 input, 1 output. These outputs are combined using an OR gate, so that we will get a only one greater output. Therefore, now it's the condition of the. Now we must implement the selective lines. So 4:1 multiplexer can have 2 selective lines, S0, S1. This one also can have S0 and S1. Now what I will do is, I will write the truth table first and I will show how can we implement the another one S2. That is another selective lines S2. So if we see the truth table, S2, S1 and S0 will act as an input because these inputs will be selected using these selective lines. Output is Y. Since we have 3 inputs, what will be their combinations? So the combinations will be 4041, 2021, 2021, 01, 01, 01, 01. So now let's assume that if S2 value is 0, S1 value is 0 and S0 value is 0, we will get the output Y as I0. Next, I1, I2, I3, I4, I5, I6 and I7. Okay, now we have already constructed S1 and S2. S1 and S2 is already here. Now I must add another. Now we already constructed S1 and S0. S1 and S0 selective lines are already there, but S2 is not there. How to implement S2? So we must take it from the outside because one 4:1 multiplexer can have only 2 selective lines. So what I will do is I will give an external selective lines. I will use an external selective lines S2. So I will give the direct connection to this 4:1 mux, and while giving to this 4:1 mux I will use an NOT gate. Therefore when S2 value is equal to 1, when S2 value is equal to 1 from here to here, I4, I5, I6, I7 will be activated and the output will be coming through it. Next, when I give 1 here, so while going to this 4:1 multiplexer, the value will be complemented. That is, if I give 1, it will be 0. So if S2 value is equal to 0, these conditions will be activated. That is, this 4:1 multiplexer is activated and I0, I1, I2, I3. In these inputs, one output will be coming. So hope you understood the concept of the 8:1 multiplexer designing using 4:1 multiplexer. If you like the video, please subscribe for more engineering related topics, and if you have a doubt, please comment below. I will clarify it. Thank you.